Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Good afternoon. It's me again, Irad, your physical science teacher here live at Teleradyo Marcelo ang telearalan ng bawat Maloleño. First, I would like to acknowledge our beloved school principal, Dr. Maria Victoria Civivo, my master teachers, Ma'am Rosita A. Elopre, and Sir Bartolome Asa, and to all the faculty teachers, and to all the grade 11 students tuning in with us here at Teleradyo Marcelo. And I hope everybody is doing good. Okay, today, we are going to talk about formation of heavier elements in the universe. Here are our objectives. Okay, by the end of this session, you should be able to first differentiate ionic, polar, and non-polar bonds. Second, determine polarity of chemical bonds between atoms using concept of electronegativity. Third is to familiarize the different molecular shapes. And fourth, of course, explain how polarity of molecules related to its properties. Okay, so if you can remember, in your grade 9 chemistry, you have tackled the lesson on the periodic properties of elements such as atomic size, metallic property, ionization energy, electron affinity, and electronegativity. Can you still recall what is electronegativity and its connection to the polarity of bonds? Okay, so let us have this activity to assess if you still remember the said topic. You need to identify the type of bond in each picture shown in the screen. So whether they are ionic band, polar covalent band, or non-polar covalent band. Okay, let us begin with the first picture. Just simply comment your answers down below. Okay, keep your answers coming. What do you think does these pictures tell us? Is it ionic band or polar covalent band or non-polar covalent band? Okay. Okay, keep your answers coming until I see correct one. Okay, so the correct answer for this picture is ionic band. So ionic band represents this picture. So second picture. So we have here this picture. So what do you think? What is this type of band? You can send your answers now, class. So you can write down if it is ionic or covalent band or non-polar covalent band. Okay, thank you for commenting your name and your section down below. But I still need your answers. I was, for this picture, if you can remember during your grade 9 school year, this one represents as this picture produces covalent bonds. Okay, so let's review other pictures. Okay, what can you say about this picture? This is our third picture. Can you identify what kind of band we have here? So it's a tug of war between two groups. So they're pulling against each other. So what do you think? Okay, Maria Dolores de la Cruz answered covalent band. That is correct, class. Covalent band is the answer for this particular picture. Okay, for our fourth picture, just give it a try, class. So put your answers down below. What do you think? What kind of band is this? So you can write down if it is covalent band, ionic band, non-polar or polar covalent band. Okay, see, I recognize your answer, Nestle. Covalent band. Other answers? Okay, hi, Sir Alex. I see him commenting on this class. Okay, so correct. This is covalent band, but to be particular, this is polar covalent band. So that is the answer. Okay, for our last picture, definitely not the list. So what kind of band is this? Okay, I see answers. Ionic band, ionic band, ionic band. Other answers? Okay, to give hint, this is still a covalent band. But can you guess if it is non-polar or polar covalent band? Okay, so to give the answer for this picture should be non-polar covalent band. Okay, so to further discuss this, first let us have the polar covalent band. Okay, so polar covalent bands refers to the band in which the bonded atoms have an unequal sharing of electrons, represented by gamma positive and gamma negative, creates a partial separation of charge and a dipole moment. So dipole moment is represented by arrow toward more electronegative element. And covalent bonds are polar if there is a difference in electronegativity between the bonded atoms. Examples are as follows. So we have here oxygen and chlorine. These two are one of those 7 diatomic element in the periodic table. We also have here phosphorus trichloride. We have ethanol, ozone, hydrogen, water, and of course hydrogen chloride. So next we discuss nonpolar covalent band. So what is a nonpolar covalent band? It is a band, okay? Wait. So a nonpolar covalent band is a band in which the electrons are equally shared by the banded atoms. So here are the examples of a polar covalent band. So we have carbon dioxide, we have benzene, we have carbon tetrachloride, methane, and ethylene. Okay, next, so we have here ionic band. So what is ionic band? Ionic band, also known as the electrovalent band, which are formed between a metal and a non-metal due to a large difference in their electronegativities. Examples of ionic band are we have lithium fluoride, lithium chloride, lithium bromide, lithium iodide, sodium fluoride, sodium chloride, sodium bromide, and of course, we have sodium iodide. Okay. Now, let's proceed to electronegativity. Okay, what's the connection of electronegativity to the polarity of bonds? So, first, what is electronegativity? So, electronegativity is a measure of the tendency of an atom to attract electrons toward itself. We could use the electronegativity value of the atoms involved to get the absolute electronegativity difference, which will help us in predicting what type of chemical bond, be it ionic, polar covalent, or non-polar covalent, that would exist between them. So the absolute value of the electronegativity difference between the atoms gives an idea of the type of chemical bond that can exist between them. Ionic bonds results when there is a very large difference between the electronegativity values of each atom, resulting to a polar bond. And so polar covalent bonds, on the other hand, exist between atoms with high electronegativity difference value, but smaller than that in ionic bonds. And lastly, non-polar covalent bonds have the least electronegativity difference among the three types of bonds. So okay, this is an example of the type of bond based on electronegativity difference banded atoms. So first we have the magnesium and chloride. So the electronegativity they will get is 1.8 because the electronegativity value of magnesium is 1.2 and the chlorine has 3. So the difference is 1.8, and it will give as a result of ionic bond. So for the second row, we have here water. So water composed of hydrogen and oxygen. Hydrogen has a electronegativity value of 2.1 and oxygen has an electronegativity value of 3.5. So it will give us a difference of 1.4 as the electronegativity difference. And so it is a polar covalent. And lastly, we have 2 atoms of bromine. So 2 atoms of bromine, it has an electronegativity value of 2.8. So the difference will give us 0 because any value subtracted by its value will give us a 0 value, a 0 result. So hence, it is a non-polar covalent. Okay. So let us have an exercise about this. I will be reading the directions based on the metallic properties of element. Predict first if the bond between the pairs of atom is ionic or covalent. Then calculate the electronegativity difference between the atoms to further classify the bonds as polar or non-polar. Determine which is more electronegative atom in each pair. So for letter A, we have chlorine and potassium. You can search for the value of the electronegative value of this molecule. So is it ionic or covalent bond? You can put your answers down below and I will be reading it and recognizing your answer. So what do you think a chlorine and a potassium will give us? Is it ionic or covalent bond? Okay, all you have to do is to find the difference between these two. So what is the value of the electronegative? What is the electronegativity value of chlorine and potassium? And then subtract it. And then you'll know if it is ionic or covalent. Okay, I see a lot of UMS students in here. Thank you for this, UMS people. Okay, the answer for this letter A is yes, it is an ionic bond because chlorine is non-metal and potassium is a metal. Okay, so for the second item, we have here chlorine and carbon. So let's continue. Can I have your answers and let me check it if it is correct? So you can put if it is you can guess an intelligent guess if it is an ionic or covalent band. So what do you think chlorine and carbon will produce? What kind of band? Is it ionic or covalent? Okay, I recognize people from Siemens at Lag, 11 ABM. Thank you for tuning in with us. Okay, very good. I recognize your answer, Charles Brian Banigan. So the correct answer for this is covalent band. So chlorine is non-metal and carbon is a non-metal. So it will give us a covalent band. Okay, let's proceed to letter C. We have here two atoms of chlorine. Okay, what do you think? What kind of band do you think will they produce? I will be waiting for your answers. Okay, thank you for Alexandra, Anthony, Maria Dolores, and Nestle. Arwen and Jade, all of your answers are correct. So two atoms of chlorine will give us a covalent band. So they are both non-metal. So that is the reason why we will have a covalent band. But now let's calculate the electronegativity difference between the atoms to further classify the bands as apolar or non-polar, so that we can also determine which is more electronegative atom in each pair. So for the chlorine, for letter A, we have chlorine and potassium in letter A. So what do you think is the electronegativity difference between this chlorine and potassium? So you can search for these values. It is present in your periodic table. So when you subtract the value of electronegativity chlorine and potassium have, you will get a difference of 2.2. And you will also see that chlorine is the more electronegative atom between the two. So the type of chemical bond is ionic, definitely. So the second item that we had a while ago, it is the chlorine and the carbon in letter D. So, okay, what do you think is the electronegativity difference between chlorine and carbon? So if you have a copy of electronegativity values in there, you can easily subtract these values and it will give you a value of 0.5 as electronegativity difference. Okay, very good, Ken Chadwin Takang, if I pronounce it correctly. So 0.5 is the answer or the difference between the electronegative values. So chlorine is the more electronegative atom. That's why the type of chemical bond we have here is polar covalent. Okay, lastly, we have here the letter C. We had a while ago two atoms of chlorine. And what do you think is the answer? If we have two atoms of chlorine, or if we have two atoms of any kind of element or any kind of molecule, it will give us electronegativity difference of, what do you think, class? Okay, very good, Charles Brian Banigan. So 3 minus 3 is equal to 0, and any number subtracted from its number, so will give us a 0 value. So the electronegativity difference of two atoms of chlorine is 0, and that there is no more electronegative atom because they have the same electronegativity. The type of chemical bond in here is definitely a nonpolar covalent. Okay, so enough for that exercise. Now let's proceed to molecular geometry and property, or the molecular geometry and polarity. So the polarity of covalent bonds. Okay, the polarity of covalent bonds in a molecule helps determine the polarity of the whole molecule. A molecule whose bonds are all nonpolar in character is likely to be nonpolar overall. However, not all polar covalent bonds results to polar molecules. Molecules' polarity is also affected by the molecular geometry, which in return is influenced by the electrons in the molecule. These electrons that have a significant effect on geometry are those that can be seen in the Lewis structure of molecules. So first, what is molecular geometry? So this molecular geometry represents the 3D arrangement of atoms in a molecule influences the polarity of a molecule, determined by the bonded and unbonded lone pairs of electrons surrounding the central atom. The molecular geometry affects the polarity of the whole molecule. A molecule assumes a geometry that minimizes the energy of repulsion between the electrons in the valence shell of the atoms. So what defines the polarity of a molecule? So let's look at the next slide for the common molecular geometry. So we have here the linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral with corresponding lone pairs and number of electrons dense area. So you can see here, you can see it here in the picture. Okay. Okay, next. So we have here VSEPR. So what is VSEPR and how does it work? The value shells, the valence shell electron pair repulsion theory or VSEPR theory. Again, valence shell electron pair repulsion theory or VSEPR theory. It helps us predict the spatial arrangement of atoms in a polyatomic molecule. These shapes or this shape is designed to minimize the repulsion within a molecule. So what about the guidelines to determine the VSEPR of a molecule? Okay, symmetry plays an important role in determining the polarity of a molecule. There are guidelines to determine the VSEPR shape of a molecule. Molecules are polar or nonpolar based on the type of covalent bond and its molecular geometry. So here are the guidelines of VSEPR. So first is to determine the central atom of a molecule. The central atom is the least electronegative element. Second is to count how many valence electrons the central atom has. A third, count how many valence electrons the side atoms have. Fourth is to create the appropriate Lewis structure of the molecule. Fifth is using the Lewis structure, this one as a guide, determine the appropriate VSEPR shape for the molecule. And lastly, note how many electrons are shared and unshared. This will help us determine the appropriate VSEPR shape. Okay. So I think that's it. So let us now have this assessment. I will be reading the questions and the choices twice, and you can comment the letter of the correct answers down below. I see 41 people tuning in right now. Thank you for staying. Okay, so first question. We have here, what kind of bond do you have for fluorine and chlorine? Letter A, nonpolar covalent. Letter B, polar covalent. C, ionic. D, electronegativity band. Again, what kind of bond do you have if you have fluorine and chlorine? A, nonpolar covalent. B, polar covalent. C, ionic. Or D, electronegativity band. So all you have to do is to identify if fluorine and chlorine is a metal or non-metal element. You can put your answer. You can comment the letter of your answer. Okay, very good, Maria Dolores de la Cruz again. So she says the correct answer is polar covalent. Covalent, and yes, it is polar covalent is the type of bond that you will get when you have fluorine and fluorine. Okay, for number two, okay, the question is, or the statement is, the polarity of a bond between two elements can be best described by A, the difference in electronegativity between the elements. B, the difference in first ionization energy between the elements. C, the number of electrons shared in the bond. Or letter D, the difference in atomic ratios between the elements. Again, the polarity of a band between two elements can be best determined by letter A, the difference in electronegativity between the elements. Letter B, the difference in first ionization energy between the elements. Or letter C, the number of electrons shared in the band. Or letter D, the difference in atomic radius between these elements. Okay, so we have here Anthony Salamante. So he says that the correct answer should be letter A. And yes, it is. Letter A, the difference in electronegativity between the elements. Okay. So for number three, for item three. Okay, question here. Which formula represents a polar molecule? Again, which formula represents a polar molecule? Letter A, hydrogen gas. Letter B, H2O or water. Letter C, carbon dioxide. Or letter D, carbon tetrachloride. Again, which formula represents a polar molecule? Letter A, hydrogen gas or H2. Letter B, H2O or water. Letter C, CO2 or carbon dioxide. Or letter D, carbon tetrachloride. Okay, I saw Ken and Christina Nestle answered letter B. And yes, it is the correct answer for number three. H2O or water is the formula represents a polar molecule. Okay, for next item. Number four. Okay, number four. The ability of an atom to attract electron to itself is called A, geometry, B, conductivity, C, electronegativity, or D, ionization energy. Again, the ability of an atom to attract electrons to itself is called A, geometry, B, conductivity, C, electronegativity, or D, ionization energy. I thank you, Charles, for consistently participating. So the correct answer is letter C, or correct again. So letter C. Electronegativity is the ability of an atom to attract electrons to itself. Okay, so for the last item, or the last assessment problem, the question is the molecule shown in the diagram can be best classified as A, polar covalent molecule, B, nonpolar covalent molecule, C, ionic compound, or D, nonpolar ionic compound. Okay, again, the question is the molecule shown in the diagram can be best classified as A, polar covalent molecule, B, nonpolar covalent molecule, C, ionic compound, or D, nonpolar ionic compound. Okay. Okay, so it is Charles again. So the correct answer, and Anthony also got it correct, even Kim. So the correct answer is letter B, nonpolar covalent molecules. So this diagram that you are seeing on your screen is an example of a nonpolar covalent bond. Okay, so this is the summary of the answers for that 5-item assessment. Okay, so out of 5 assessment questions, if you think you got at least 4 correct answers, then you are ready to move for next week's topic. But for those who didn't, and if you still have questions, don't hesitate to personally message me, Irad, or any of our physical science teacher here in Marcelo. Okay, so now if you don't have any question, I would like to introduce to you the members of the production team. Okay, so yours truly, Irad, your teacher broadcaster for today, and our scriptwriter, Ma'am Josephine Nicolas, and our technical director, Ma'am Joy Presimay Bulaong. And of course, I would like to thank the whole Teleradyo Marcelo team for assisting us. And please don't forget to like, share, and subscribe to its YouTube channel and Facebook page. Okay, so I am hoping that you had a good time having this lesson. So see you next week. Keep safe and God bless us all.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.